EDM 60204, measurement and geometry. Okay, so we can divide this revision into two parts. One will be, which is part 1. Okay, part 1 will be all the generic topics, which actually covers measurement, and also it covers geometry. Okay, so the generic topics that actually covers measurement and geometry are, for example, okay, the generic topics. Key ideas and aims of teaching both measurement and geometry. And then we have the learning theory. Okay, we have the learning theories, and then we also have what we call as the pedagogical principles. Okay, so we do need to look at the learning theories and the pedagogical principles when we design activities for measurement and geometry. Misconceptions. Okay, and we look at misconceptions versus mistakes. Okay, so what are misconceptions and what are mistakes? Now, for learning theories, we can use all the learning theories for measurement, okay, we can use all the learning theories for geometry, but for geometry we have a special one, which is Van Hill. Okay, so this one is for geometry. Now, geometry can use all that the measurement can use, okay, for learning theory, but Van Hill is especially for geometry. And after that, we have, after misconceptions, we have teaching strategies. Okay, teaching strategies. So these teaching strategies would be a guide for you, especially when you want to design any form of activity. Now, when we talk about Van Heel, let's have a look at Van Heel for a bit. Okay, Van Heel, geometrical thinking. Okay, for Van Heel's geometrical thinking, this one is especially for geometry. So any geometry topics, you can use Van Heel's geometrical thinking. And then it starts with level 0, which is visualization. Okay, and then we have level 1, okay, which is analyzing. And then we have level 2, which is informal deduction. Okay, so you should know at each level what actually is happening in the minds, or how the students actually process at each level. Okay, so for that, you should know that at level 0, visualization means that it is when students look at shapes as a whole. Okay, and then non-verbal communication. So they see it as a whole. They don't actually talk about the shape much, but they know what it is. Analyzing is where they start to identify, okay, properties. Right, so they identify properties, they talk about the properties, they discuss about the properties. So to them, the properties of the shapes are very important, all of them. And then for informal deduction, this is where they find the relationship, okay, between properties. They use the properties to actually find the relationships among the shapes that they have learned. So this is actually for Van Heel. And under geometry, you have 2D shapes and 3D shapes. 2D, 3D shapes, and also pattern is the same. They use Van Heel's geometrical thinking. Now, apart from Van Heel's geometrical thinking, we also have spatial sense. Okay, so in spatial sense, sorry. Alright, so in spatial sense, you should know that students should be able to, okay, mentally rotate shapes, okay, from a certain orientation to another orientation using their mind. And then there will be a spatial perception. Okay, spatial perception. And in spatial perception, this is where the students actually will be able to notice how shapes would look like if you actually cut them at different angles. Okay, so they would be able to visualize or manipulate the shapes, okay, in space. So visualization. This is where the students will be able to identify or find hidden figures, okay, in which is embedded in a distracting background. So that is spatial visualization. So spatial sense is important, okay, for most career jobs, such as engineers, doctors, teachers, okay, what else? Architects, interior designers, even cooks, okay, even chefs, right? So, no matter what job you hold, spatial sense is important, right? And you have watched the video where a school somewhere in the Middle East, right? They took one whole day to develop, okay, to develop spatial sense. So that means spatial sense can be developed. It's just that you need to do a lot of exercises. Your students would also need to do a lot of exercises. So please do develop your students' spatial sense through activities. You can watch that video again and get an idea of the activities that you can design for your students. Okay, so these two, Van Hills, okay, Van Hills, right, and also spatial sense. Now these are the two learning theories which are important for geometry. Now, geometry can also use behaviorism. Geometry can also use developmental, cognitivism, or constructivism. You can include that into your, you can use that as part of your learning theory. Okay. All right. So after looking at this, so after we have looked at the generic information for both measurement and geometry, we actually that this is part 2. Okay, part 2 is where we talk about or discuss more on the subject itself. Like, for example, for measurement, okay, we look at measurement and we look at some of the key ideas, okay, found in measurement. Okay, so for example, for measurement, we look at the difference between mass and weight. Okay, and in the recorded lecture, I also included experiments which I did, what a mass is and what weight is, and how do you actually measure mass and how do you actually measure weight. Okay, so mass, you can use your weighing balance or your weighing scale, but for weight, you need to use Newton meter. And after that, we look at time. Okay, we look at time and what is time. We have 12 hours and 24 hours. So you need to be very, how should I say, well versed, okay, when it comes to time, okay, where we have 12 hours and also we have 24 hours. How do you read the 12 hours and how do you read the 24 hours. And we also have the AM and PM. Okay, so yeah, you also need to be able to explain that as well. Okay, and for measurement, we also looked at parameter and area. Okay, parameter and area, how to calculate parameter and area of different shapes. Okay, some you can just use the information given, but some, if let's say the shape is not regular polygons, then you might use if it is not so straight, then you do need to use rope or thread. Okay, and you need to know how to measure that, as well as you need to know how to measure using different types of apparatus or equipment. Okay, so we have already gone through that. And we also looked at some misconceptions. Okay, misconceptions when it comes to measurement. So we looked at some misconceptions. Sorry. Okay, some misconceptions which are quite serious if you don't address them. It will be serious if you don't address them. And we have looked at how researchers identify the 5 misconceptions and how actually or what actually it meant. So I've gone through that in length. Okay, so please do look back at the lecture video.
We also looked at parameter and area, misconceptions, speed, and volume. So under volume, we looked at capacity as well. So you need to know the difference between volume and capacity and which one you will be teaching your students. Give them examples. Okay, so the next part is on geometry, and under geometry we have 2D shapes, and under 2D shapes we have regular and irregular 2D shapes. Okay, so you need to show your students what are the differences between these two. Next we have 3D shapes, where it actually began from 2D shapes. So you need to show how 2D shapes actually represent the 3D shapes. Next, we looked at nets. So under nets, we are actually using spatial sense because you really need to put together the patterns, the nets, to come up with the 3D shapes. Next, we look at patterns. And under patterns, we actually go for core pattern because that's the main one. And then we have tessellations, spatial sense, patterns. We identified the core pattern, and then tessellation, okay, and how to name the tessellation. And apart from that, we looked at lines, line segment, and array. But then we compare between these three. And apart from that, we also looked at parallel lines and perpendicular lines. After that, we also went into looking at angles. And for angles, we have acute angles, we have right angle, we have obtuse angle, and we have straight angles, reflex angles, as well as full rotation angles. So for angle, you need to define, okay, the angle, which means the about turn of something. And then we also looked at transformation. We have resizing, whether it's smaller or it becomes bigger. And then under transformation, we have reflection. We also looked at the line of symmetry for reflection, or the reflection line. And then we also looked at translation. Okay, so in translation is the movement of an object to another place. And then we have rotation as well as symmetry. So part 3 is where we actually looked at generic topics. So the generic topics are, for example, here, academic tasks, and also how to plan lessons, and also SOW, or scheme of work, which you need to do when you're a teacher for the whole week. And then we have 3 types of assessments: assessment for learning, assessment as learning, and assessment of learning. Now, assessment for learning, as I've discussed before, it means formative assessment. For assessment as learning, it's self-assessment for the student, and we as teachers, we give feedback. AOF, or assessment of learning, means summative assessment, which is the summation of all that you have taught them, and they sit for the final exam. And that's it. All the best.